Hello and welcome to another exciting pre-calculus video. In this one, we're going to start looking at section 4-5, graphing the sine and cosine functions. And we have 4 bullet points: sketch and graph the basic sine and cosine functions, use the amplitude and the period to help sketch graphs of sine and cosine, sketch translations of the graphs of sine and cosine, and use them to model and solve real-life problems. So first, here I got a little sort of video clip. Here on the left, this is the unit circle, and we are going to unwrap the unit circle. We're going to roll it out and make our graphs from that. Here on this is our this would be the x-axis, or in this case, it's going to be the angle axis. Notice it goes a little bit past 6, because this about here is going to be 2 pi radians. 3.14 is going to be roughly right here. That's 1 pi radians. And then we'll have a half pi and 3/2 pi. Now when I hit play, the first thing that's going to roll out is the sine wave. Remember, from the unit circle, the sine wave, or the sine value, is also the y coordinate. So starting here at 0, our y coordinate is 0. When we get to the pi over 2, we're at our maximum height of 1 for the y coordinate. At pi, we're back at 0. And then here, we are at -1. And from -1, we're going to go back to 0. So you're going to see this roll out as a wave function. Again, sine starts at 0, so this graph starts at the origin. So here we go. The unit circle is going to go around, and this red or green graph rolls out. This is the sine wave. There we are at our peak. Now we're coming down here to 1 pi. We should cross the x-axis at 1 pi. And now we're heading down into negative y value territory. We're at the bottom of the unit circle, 3/2 pi. And now we're coming back up, and we're going to end back at 0. Next up will be cos. Cos is the x values, and we start with our x value at 1, so the cos starts here at a peak. And now we're coming down the hill. We cross the x-axis, and we're coming down here to our lowest value, -1 for an x value. And now we're heading back towards 0 at 3/2 pi. And then the show is over when we get back to 0, or 2 pi radians. And notice here we're ending back on a peak. Cosine here started on a peak, it ended on a peak. The sine wave started at the origin, it crossed the x-axis once, and then it ended when it got back to the x-axis. So let's dive into these graphs a little deeper. In this section, you're going to study techniques to sketch the graphs of sine and cosine. The graph of the sine function is a sine curve. In the figure below, the black portion of the graph represents one period of the function. It's also called one cycle of the sine curve. The gray portion of the graph indicates the basic sine curve repeats indefinitely in both positive and negative directions. The graph of the cosine, we'll see that on the next slide. Recall from the last section that the domain of sine and cos is the set of all real numbers. The range, or the outputs of the function, are -1 to 1, and that each function has a period of 2 pi. Do you see how this information is consistent with the basic graph shown? Okay, let's again look at here. Do we got it? So here's both graphs at once. Again, the black part here, I'll highlight it in red. This is one cycle. Sine starts at the origin. It's going to end at 2 pi later. It crosses right in the middle at pi. Get on there. And if sine is positive, positive sine starts by going to a peak first. So here's positive sine, it goes to a peak, and then it crosses the x-axis, and then it has a valley, and then it finishes back on the x-axis. Now on the other hand, if we have negative sine also starts at the origin, but negative sine will go to a valley first, and then it'll cross the x-axis, then it'll have a peak, and then it'll end back on the x-axis. And if you look over here on the right, I have a 1 there. You know, the black ink, y equals sine x. That's the basic sine function. But remember, there's an implied 1 in front of sine. We're going to see what happens in this video when we mess with that number. And there's also a 1 implied in front of the x. We're going to see what happens when we mess with that number. Now I do have a +0 in the parenthesis. We'll see that in the next video. And then outside the parenthesis, we could add or subtract some other number. And that's also going to shift our graph, but that'll be in the second video. Oh, and let me point out here in the sine wave, to graph it, we need 5 points per cycle. Where we begin, where we end, sine crosses in the middle, and we're going to have a peak and a valley. So there's 5 key points to graph this. Now let's look at cos. Cos is very similar, but cos starts at a peak. Positive cos starts here at a peak. So the first of the 5 dots is where we begin. We begin on a peak. We are going to end on a peak. That is the last dot in this cycle. In between the peaks, there has to be a valley. That's going to go all the way down here. So there's our third dot. And between any peak and valley, we are going to have to cross the x-axis. And also on the way back up. So here are the 5 dots for a cos wave. And again, notice over here, this does go on infinitely many times on each side. The graph is never going to end. We're just highlighting here one cycle. One period of the graph covers 2 pi radians. That will be hit with 5 key points to draw our graph. And notice here on both of these graphs, our high point is 1, our low point is -1, just like on the unit circle. Our output values, our y values, are always between 1 and -1. Same thing here on the cos graph. We go from +1 to -1. To sketch the graph of the basic sine and cos functions by hand, it helps to note the 5 key points, the intercepts, the maxes, and the mins. So just to hammer this home, when I graph a sine wave, and this is the order I do it, I find my starting point. And when I know what the period is, that is my second point, my ending point. So that's my first dot, my second dot. I know that sine crosses in the middle. No matter what those values are, sine's going to cross right in the middle. And then if it's positive sine, we start by going to a peak. If it's negative sine, we start by going down into a valley. So here we are at the origin. Our first one is a peak, and then we cross at 3, and then we have our final valley there at 5. Connect the 5 dots with a smooth flowing curve, and you have the sine wave. Now for cos, again, the order I would do it, positive sine is going to start on a peak. That's my first dot. And when I know the period, I jump to and mark the ending dot. That's my second dot. In between these 2 peaks, right in the middle, must be a valley. That's my third dot. And then between any peak and valley, we got to cross the x-axis. And between any valley and the next peak, we got to cross the x-axis again. So there are the 5 dots. Remember, on the unit circle, there are 4 quadrants, and each of these is a quadrant. You know, here's where we begin. Our first peak is quad 1, and then there's quadrant 2, quadrant 3, quadrant 4. 2, 3, 4, just like on the unit circle. Same here. First quadrant, second quadrant, third quadrant, fourth quadrant. And we've gone all the way around the circle, so that is a cycle. And let me just put here, positive cos begins on a peak and then goes down. Negative cos is going to begin in a valley and then go to a peak and end in a valley. All right, we get to do one here. Sketch the graph of y equals 2 sine x. Ooh, now did I miss a slide where they talk about the amplitude? Or did I get my slides in the wrong order? Aha! I should have this one first. In the remainder of this section, you're going to study the graphic effect of each of the constants a, b, c, d in these equations. So here they've got a sine of b times x plus or minus c, and they put this d value at the beginning. It could be at the end. You could have a plus d as long as it's outside those parentheses. So the a is the amplitude. We're going to mess around with that in this section, and also the b value in front of the x. And here's the same function for cos, some number cos, and then we might have some number multiplied by the x, and then add or subtract a number in the parenthesis, and there could be an add or subtract some other number outside. So the constant factor a in this a sine x act as a scaling factor, or a vertical stretch or vertical shrink of the basic graph. If that a value is greater than 1, the basic sine curve is stretched. If it's a fraction or less than 1, the basic sine curve is shrunk. The result is that the graph of our sine x ranges between positive and negative a instead of positive and negative 1. The absolute value of that number is the amplitude of the function. The range of the function for a's greater than 0 is plus or minus a, will be our output highs and lows. So the amplitude of our function, a sine x and a cos x, represents half the distance between the min and the max of the function and is given by this. The amplitude is the absolute value of that number. So when we go back here to this, I look at y equals, I'm just going to write it a little bigger here, 2 sine x. So it's still just sine of 1x, so we don't have to worry about the amplitude or the period being changed, but we have this 2 here. And that means our graph will go from a high of positive 2 to a low of negative 2. And they also give us an interval here, negative pi to 4 pi. So I'm going to do it like this. I'm going to go out way as far as I can here and make that 4 pi. And I'm going to eyeball it, cut it in half. This is 2 pi. And then, of course, I'll put the other whole numbers in there. There's 3. And here's 1 pi. And they do want us to go to negative pi. So I'm going to eyeball this distance and put it right here. That's negative pi. Now I'm going to mark but not label the half pi's. So there's negative a half, positive 1 half, 3 halves, 5 halves, 7 halves. Okay, now the period is equal to 2 pi. So I'm going to have one cycle from 0 to 2 pi. So in this amount, I'm going to do my 5 dots. I'll switch to red ink here. It is sine wave, so it's going to start at the origin. And I know the period is 2 pi. So if I start at 0, I'm going to jump to the end. That's 2 pi right here. And I know that the sine wave is going to cross in between these intercepts. So we've got another one at x. There I got my first 3 dots. And now I look again, it's positive sine. So when we start at the origin, we are going to go to a peak first. And if we go up here to a peak and come down, that means we're going to cross the x-axis and we'll go down into a valley here. And that will be, come on, there's our 5th dot. So there's one cycle of our sine wave. Now they do want us to go all the way out to 4 pi, so what I'm going to do is just sort of move this over, and I'm going to switch to black ink so we can see where the different cycle begins and ends. So now I'm going to sort of pretend that this is my origin, this is where my graph begins. I'm going to jump 2 pi to the end, that's the period, so we're going to end at 4 pi, and the sine wave is going to have an x-intercept in the middle. And of course, we're starting a new cycle. That means we're going to start here and go to a peak, and then we'll cross at 3 pi, and we'll come down into a valley, and we'll have a valley right there. So to continue my smooth flowing sine wave, it's going to look like that. All right, now they do want us to go 1 pi to the left. Now notice something here on the graph. We're starting at 0, and between 0 and pi we have a parabola down. Between pi and 2 pi looks like a parabola up. 2 to 3, parabola down. 3 to 4, parabola up. So notice the pattern. Every 1 pi, we're doing sort of like a parabola above the x-axis or below. So if I'm going to go from this origin, if I was up here at this peak, I'm coming down, that means this one is going to look like that. And that continues with the flow of our sine wave. So that is 2.5 cycles of 2 sine of x. And we talked about this. I just had my slides in the wrong order. Example 2. On the same coordinate axes, sketch each of these functions. First one is half cos x. The next one is 3 cos x. So they're very similar. The only difference is the 1/2 and the 3. And let me do this. I'm going to stretch this out a little bit. And it doesn't tell us how many cycles to do or how far to go on the x-axis. So we're just going to do 1 cycle. So we are going to start at the origin, and we'll go to 2 pi. And I'm going to eyeball that, cut it in half. That's 1 pi. And then here this would be 1/2 and 3 halves. And for my y-axis, I've got the first one is 1/2. So I'm going to come down to about here, and make that positive a half. Same distance below, negative 1/2. So those are the highs and lows of my a function. Let me do this one here. I think I'll use red ink. So I'll underline that in red. We're going to do a cos wave from 0 to 2 pi. So it's cos, and it's positive cos. Positive cos starts at a peak. 2 pi later, we're going to jump to the end of the cycle. It's going to end on a peak. It begins where it ends. They're both going to begin and end on a peak. In between these peaks, right in the middle at pi, we're going to have a valley. Down here to negative 1/2. To get from my first peak to my first valley, I'm going to cross the x-axis, and it's going to happen right at a half pi. And then I'm in my valley at pi. I want to get to the peak at 2 pi. I've got to cross the x-axis again. Do not connect your dots like this. That is not a cos wave. That looks more like an absolute value. Remember, what we did here is unwrapped a circle. So it's going to be smooth flowing curves, sort of like that. All right. Next, I'll go back to black ink. Y equals 3 cos x. The cos x is the same. The only difference here is the 3. So this is not to scale, but I'm going to go way up here. That's positive 3. Same distance down here, negative 3. So the highs and lows change, but everything else stays the same. Once again, it's positive cos, so we'll begin on a peak, and then we will end on a peak. In between the peaks, there has to be a valley right below pi, all the way down here at negative 3. And if I go from my first peak to my first valley, I have to cross the x-axis. It's going to happen at the same spot as the red graph, and that is going to occur again on the way back up. So we connect the dots with a smooth curve, sort of like that. So the change in amplitude, the 1/2 and the 3, stretches our graph up and down. And here we just did one cycle from 0 to 2 pi. Again, 5 dots. 1, 2, 3, 4, 5. You know from a previous section that the graph of negative of f of x is just a reflection of the graph across the x-axis. I talked about this. It's just going to change where you begin and end. Let me just do this again. So here I'm just going to do in black a couple of axes. If it's positive sine, you start at the origin and go up. If it's negative sine, you will also start at the origin, but you'll begin by going down. Peak first for positive sine, valley first for negative sine. And if you have positive cos begins on a peak and heads down into a valley. And if you have a negative cos, that's going to start in a valley and head to a peak. So that is just a reflection across the x-axis. So we've talked the amplitude, now the period. And we saw this, y equals a times sine of b times x. So if you put a number here where this b is, it has to be touching the x. It multiplies by the x. The period is going to be changed by that number. And what you do is take 2 pi, the trip around the unit circle, and you divide that by whatever number is touching x. 2 pi divided by b is the new period, and that period will be graphed with the same 5 dots. So for the period, 2 pi divided by the number in front of x. Note that if that b value is a fraction, if it's less than 1 but positive, is greater than 2 pi and represents a horizontal stretch of the graph. It's going to stretch us out. Similarly, if b is a number bigger than 1, the period is going to be less than 2 pi. It's going to shrink us up. It's going to scrunch us up closer to the y-axis. If b is negative, blah, 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 forget that. Okay, here we go. First one, y equals sine of x over 2. Now, I'm not a big fan of having the x on top of the fraction. Another way to look at that as the sine of 1/2 x. So let's identify first the amplitude. The number in front of sine is just a 1. So that tells us we're going to go from 1 to negative 1 on the y-axis. And now we're going to figure out the period. The period is 2 pi divided by the number in front of x, 1/2. How do you divide 2 by a half? Well, you invert and multiply. Bring that fraction up and flip it. Now it's 2 over 1. If we multiply 2 pi by 2, we get the period is 4 pi. Now, in the example, they did not tell us how many cycles to graph, so let's just graph one. Since our period is 4 pi, we're going to go from the origin out this far. I'm just going to call that 4 pi. And I'm going to eyeball it, cut that in half. That's 2 pi. Eyeball that, 1 pi. And then here, 3 pi. Now we don't need the halfway marks, but I'm just going to mark them. All right. So one cycle from 0 to 4 pi. Amplitude is 1. We've already got that. It is positive sine. Positive sine is going to start at the origin and head to a peak. But let's do, there's our first dot. Our last dot is at the end of the cycle, 4 pi. Sine wave is going to have an x-intercept in the middle at 2 pi. And then right in between 0 and 2 pi, we're going to have a peak at pi. And that means we'll cross the x-axis and have a valley at 3 pi. So here's our smooth flowing sine wave. There we go. One cycle of sine of half x. Here's some practice problems for you to try. So pause the video and give these a try. See what you can figure out. Notice here it does say include 2 full periods. The first one here, you're not graphing it. The graph is provided. And then also 24, it does not tell you to graph it. It just says describe the relationship. Consider amplitude, period, and shift. So pause the video and try those. See if you get them right. Okay, amplitude and period on this one. Again, they give us the graph, they give us the function. Amplitude is just the number in front of the function. So that's 3 cos, so the amplitude is 3. We'll go, and you know, if that was a negative number, if they want the amplitude, it would be the absolute value. The amplitude, this for right now, we can say how high above and below the x-axis will our graph travel. Now to find the period is a full 2 pi divided by the number in front of x, so the number touching x there is a 2. So we'll divide those out. The period is just 1 pi. Get these out of the way. Describe the relationship. Okay, well, let's talk amplitude first. The amplitude of the first one is 1. The amplitude of the second one is also 1, so they're the same in that regard. Period. This one is just sine of 1x. Period is 2 pi divided by that number in front of x, so that period is just 2 pi. But down here, this period is going to be 2 pi divided by the number in front of x, 3. 2/3 pi is the period. And we haven't seen shifts yet. That's the next video. Okay, now here we actually get to graph some. Graph them on the same axes, include 2 full periods. Well, this top one here is going to have the bigger period, so we'll do that one first. There we go. And I'll do this one here in red. Our biggest number between these is 2, so that's going to be as high as we go to, as low as we go to -2. And now this one, the period is 2 pi divided by the number in front of x, and that's a 2. So the period of one cycle is just 1 pi, but they do want 2 full periods. So we are going to go out here to 2 pi, and we'll cross that at 1 pi in the middle. And there's half and 3 halves. I guess I can label those. All right, back to red ink, and we want to do 2 full cycles of this. Remember, the period is pi. Positive cos is going to begin at a peak. 1 pi later, we're ending at another peak. That means we're going to have a valley here at a half pi all the way down here. And we'll cross at 1/4 and 3/4 pi. So here's our first cycle. There we go. And let's do another cycle. So here we are at this peak at pi. 1 pi later at 2 pi will be done. Another peak. In between the peaks, right in the middle, must be a valley. So we're going to have a valley there. And we will cross at 5/4 and 7/4 pi. So there is our second cycle. Now I'm going to switch to blue ink for this one. Now this one, it's negative and it's 1 cos. So this is going to have an amplitude from 1 to -1. And let me get a little more room here. Period is 2 pi divided by the number in front of x. That's a 4. So 2/4 or 1/2 pi. So this has a very compacted period, half pi. So look down here on the graph from 0 to a half pi. We're going to have a full cycle, 5 dots in between 0 and a half pi. And because it's negative cos, we begin in a valley and we're going to end in a valley right there. So that means right in the middle at 1/4 pi, we're going to have a peak up here to 1. And that means we're going to cross at 1/8 and 3/8 pi. So here's our first cycle. And then we can repeat that cycle from 0 to half pi between half pi and 1 pi. So this now becomes dot 1. Dot number 2 is where we're going to end in another valley. The third dot will be at 3/4 pi. That's our peak. And then we'll cross in between the peaks and the valleys. And there's 2 cycles of negative cos 4x. And that would just continue. We could keep doing that if we felt like it. Do more cycles on there, because these do go on infinite in both directions. So that's actually 4 periods of negative cos 4x and 2 periods of 2 cos 2x. Now, this will be good or bad news depending on your feelings toward WebAssign. The program is not good at graphing. You're going to just have to choose multiple choice which graph is the correct one. I'd rather see you graph them by hand from scratch. So most of this graphing stuff is going to be textbook work. Don't forget you do have the online version of the book available through WebAssign. But for 5-day 1, look at page 304. Here are 5 problems. Don't graph the ones you don't have to graph. Make sure you read the directions. If they tell you to do 2 cycles, make sure you do 2 cycles. And I will see you in class.